was 655, I think, and 6.2, substitution and regions between curves. Homework. Yes, Sam.
You said the integral or number 24 on succession.
Which page? 391 or the other one?
6.2, which is page 406.
Yeah, 6.2. And number 24.
Yeah, did you just settle the integral? You don't have to do the whole thing.
Okay. So there are two functions. We have x equals minus sine of 2y. And that kind of looks like this. Sine curve on its side. Or if you like, an inverse sine curve. And the other curve is x equals cosine of y. And there's one, and then here. And we're trying to find the area in here. So the first obvious thing about it is it'll be much easier to integrate along the y-axis. So we want to set up integral dy. And so we want to take this function and subtract this function from it. So we'll get this area in between. So it would be minus sine 2y minus cosine of y. And now we have the question of what are the points we want to integrate from here to here. They give you a pretty good hint that the upper point is pi over 2. But we'll figure that out more directly. You also could just substitute it in, and we see that sine of 2 times pi over 2 is 0, and cosine of pi over 2 is 0. So we actually know that's an intersection point. But the way you would need to solve these is you look for where they're equal. So we would set sine of 2y equal to cosine of y. And I think I kind of advisedly warned you that you're going to need all the math you've learned in this class. So we have to step back. If you've been at Foothill for a while, you may have taken Math 48C. But if you haven't, you've taken a trigonometry class somewhere, and you should know how to expand sine of 2y. So sine of 2y is sine 2 sine of y cosine of y equals cosine of y. I did this earlier with someone in the class, and I kind of did it wrong. I didn't do it wrong, I just didn't do it really carefully. I'm going to do it really carefully now. So I'm going to subtract cosine y from both sides. I'm going to have negative 2 sine y cosine y minus cosine y equals 0. And I might as well multiply through by minus 1. And now I'm going to factor. So I have cosine of y times 2 sine of y minus 1 equals 0. So that tells me that the points of intersection are going to either be at cosine of y equals 0, or sine of y equals 1/2. All right, let's create a little table of those. Where is the cosine of y equal to 0? Okay, that would be at pi over 2. And where else? What's the cosine? I like to draw these little diagrams in. Okay, so over here or over here, which would be negative pi over 2 or like 3 pi over 2. All right, so where does sine of y equal 1/2? So 1/2 is, of course, part of a 30, 60, 90 triangle, right? So here and here. Does that look right? Oh, nobody caught this. Plus, minus, minus. So actually, it's over here, which is negative pi over 6. All right, that's what this looks like here. Negative pi over 6. Let's check. So negative sine of negative pi over 6 times 2 is negative pi over 3. So what's sine of minus pi over 3? That's negative 1/2, right? Wait a minute. Negative 1/2. So this would be positive 1/2. And now let's look at cosine of pi over 3. Cosine of pi over 3. That looks like, no, I did this wrong. Oh, cosine of pi over 6. Pi over 6. Yeah. Okay, I did it right earlier. It was much easier. Anybody want to help me out here? No. Okay. So this is negative 1/2. Sine of y negative 1/2. I have to go back to trigonometry now. So here and
Negative 5 or 6.
negative 5 or 6. That's what I had. Why didn't that work? What's the negative sine of negative pi over 3? Oh. Sine of negative pi over 3, that's negative square root of 3 over 2 times a negative, so it becomes a positive square root of 3 over 2. So that's where this function, right? And cosine of negative pi over 6 is the same thing, right? Cosine of
Yeah.
exactly. Isn't that right? Okay, I'm being a little too careful here. Negative pi over 6 square root of 3 over 2. If anyone wants to call me on this, go right ahead. I will fix that other part, but this is the point you want to go to. So what that tells me is that negative pi over 6 to pi over 2, this integral. That should give you the area. I need some coffee. I don't have any. All right, what are we, next question. Yes.
And that should be the cosine y minus plus sine 2y.
I'm sorry, is it?
But that should be the cosine y plus sine 2y.
Why don't you come up and show me, because I'm not putting 2 and 2 together. I've made a mistake, right? You think I need to subtract, you subtract this from here, right? Isn't that what I did? You think it's the opposite? Okay. Well, I'm going to suggest you may be right, but let me show you what happens if I'm wrong. Okay? It's not a big problem. Okay? So let's go ahead and find the antiderivative. The antiderivative of the sine of 2y. Okay? So the cosine of 2y, the derivative of cosine of 2y will be negative 2 sine of 2y. So we have to divide by 2, right? And the derivative of the cosine of, the antiderivative of the cosine of y is sine of y? The sine is the cosine. Okay, so that's right. So from negative pi over 6 to pi over 2. Sure wish I had a working board to pull in here right now. Okay, so cosine of 2 times pi over 2 is the cosine of pi over 2 minus the sine of pi over 2 minus cosine of minus pi over 3 over 2 minus sine of pi over 6. Okay, so that trigonometry is coming in really handy. Cosine of pi, negative 1, negative 1/2. Sine of pi over 2 is 1. Okay. Cosine of minus 3, minus pi over 3. Minus 1/2. It's minus 1/2.
And that will be minus 1/4.
Minus sine of minus pi over 6. Okay, so that's going to be,
So that's one.
isn't that a half? Minus a half? Let me draw my little circles here. Minus pi over 6, so yes, it's going to be minus a half. Okay, so that becomes plus, bringing this minus in, plus now minus. So minus a half minus 1 is minus 3/2, plus minus a quarter. 3/2. Minus 3/2, so 12. Have to go to eighths. Minus 6/8, minus 2/8. Oh, it's minus 1. Is that right?
I think cosine minus either is positive. Is positive.
So you think it's cosine of, yeah, that should be positive.
Yeah.
That had it positive, so it should have been positive, but then, so now it becomes negative, right? So it's even worse. So this is, let's convert everything to eighths. How about that? So minus 4/8, minus 8/8, minus 2/8, and then I forget, this is still minus, right? No? Yes, no? I thought someone said no. No, okay. Minus 4/8. So 4, 8, 16, 18, minus 18/8, or minus 9/4. Okay, is that maybe close? Yeah, did anybody get 9/4?
I got
Yeah.
Yeah, so you're correct, absolutely. But my result is just off by a factor of -1. That's what this tells me. I mean, remember, if I guess, if I integrate f of x minus g of x, that's just going to be minus g of x minus f of x. So you don't have to worry, when you're doing a problem like this, you don't really have to worry which is the greater function. Because if in the end you end up with a minus, you know, you made a mistake. You just change it to positive. Does that help? Okay. Yes?
So it'll always be positive.
Well, when the question says find the area of the region between two functions, they're asking for a positive area. So yes, in the end, it should always be positive.
Did you technically have negative area when you really good?
Okay. He asked the question. I'll ask you in just a second. The question was asked, is there such a thing as negative area? So,
Like when you left the y-axis.
sorry?
Like, don't you have negative area when you're like left of the y-axis?
Okay, so this is semantics, right? So I'm going to give you my understanding of the semantics. Area comes from geometry, and in geometry, all area is positive. Now we are using integrals to calculate area, but sometimes our integrals give us a negative number. So you could call that a negative area, but I would say it's just the integral gave you a negative value. Area should always, if a problem asks for area, it should always be a positive thing. I mean, I could draw an area, right? Can I draw a negative area? I don't know how to draw that.
Or y-axis.
I could say area equals this, and then minus a is a negative area, but it's just a negative number, is what I'm trying to suggest. And quite honestly, if you go into another classroom, someone, another professor with more qualifications than me say, no, there is negative area.
Well, I was just saying, could you put like a y-axis right in that area is technically negative if you drew out negative.
Well, you want to beat this up, it's okay.
Well, more importantly, I think is when you have
So
y integral thing.
we know that if we have a function, and you find the integral from a to b of this function, which is above the x-axis, that integral will be greater than 0. And you say, okay, that's the area. If you have a function below the axis, and you integrate from a to b, the number you get will be less than 0. Now, I think the orthodox way to answer your question is to say that if g of x is below the x-axis, that this is the negative, this value that you get from the integral is the negative of this area. But if you want to call it negative area, that's okay with me. I'm just giving you my point of view on it.
So the reason why I asked this is in a problem like this, I'm trying to figure out how we would know which one to subtract from, like which integral to subtract from
Yeah.
which, right?
Yeah,
That's sort of the context.
the dumb answer is the value, the way which gives you a positive value.
Okay, and we would know that because we can subtract the,
Well, you know it because if you do it the wrong way, you get a negative number, and then you
That's
just
just
switch it. But I don't expect, if you're doing that as a problem or a test problem, if you come up with, -6, and then you say, but obviously, I just want the absolute value of that, so it's 6. That's accepted. I understand it. You understand, the subtlety. I hope you understand the subtlety now. All right? Question?
In this problem, can we possibly integrate it along the x-axis?
Oh, okay. I like that question. Oh, good. It's still here. I don't have to redraw it. That shows you're a brave person. So, bravery is important in mathematics. You should not shirk away from something because it looks hard. So, let's see what we would need to do. All right? So, if we're going to integrate along the x-axis, we're going to have some kind of integral here, dx. Well, we know what this limit is, right? This is 2. Question is this, I guess this also is pretty obvious, right? This is going to be 1. X equals cosine of y, right? So we sort of know our two limits here, right? -2 and 1. But now we have a problem. From -2 to 0 here, we're adding up this guy, right? I'm just going to expand here. From -2 to 0, we want the area between here and here. And now this function, if we solve for y, right, that's going to be y is going to be equal to the minus arc sine of x over 2. But there's actually two different functions here. Here's the arc sine, and then here's the arc sine plus, some value here, right? So we already have to figure out what this function is and this function is, and find the difference between those two functions. Okay, one of them, I guess this is the arc sine, then this is the arc sine, plus a period of the sine, of this sine function. So that's already pretty tricky, right? And that's just this part of it, right? This part of it gets even more complicated, because now, from here to this point, which we've already figured out, that's -6 over pi. I'm sorry. Oh, I have these switched. I have x and y switched. So from 0 to square root of 3 over 2, we now have, again, this sine function, arc sine function, but we now have the difference between this arc sine function and this function. So that's, again, two different functions. And then finally, from here to here, we have kind of the same problem we had over on this side, which is now it's just both these arc sines come from this function, except they're off a period. Now, if you want to stay after class and you want to see if you want to see steam come from my head, I will actually do it for you. But I'm not going to do it in class because now you see why we sometimes want to go in one direction. Right? Okay. All right. Other questions? Yes.
For 6.2, number 12, so the same page.
The region bounded by y equals 2x, etc.
Yeah.
Okay.
How do you figure out which to subtract on which? Because just explain the problem.
Well, again, I'll give you I want to give you two practical ways to do it. Right? The first practical way I did, which is just randomly pick one way, and if it comes out negative, it was wrong. Do it the other way. Okay? That's the first practical way. Second practical way is to pull out your, let's see.
Yeah, I graphed it on the graphing calculator, and so just because the bounds are kind of weird.
Let's take a look here. I mean, the other thing, you can graph it yourself, right, on a piece of paper. Okay, so it didn't work. That worked a little better. Okay, so which of these is the parabola? Which of these is the second degree? Obviously the parabola. And the 2x is the line. right? You can see that, there's the line, that's the y equals 2x. So the second practical way to answer this is graph it on your graphing calculator and take a look, right? Now, let's just say you're on a desert island and you can draw in the sand, but you can't draw very quick enough because the water just comes up and knocks off any grass. And you want to know, gee, how can I possibly figure out this just with my pen and paper? Okay, so the two functions are f of x equals 2x and f of x equals x squared plus how many x? 3x. 3x minus 6. So the first thing to do is to find out where they intersect. So let's set them equal.
Negative 3 and 2.
Sorry?
Negative 3 and 2.
Okay. So I know that at negative 3 and positive 2, so I know that that's what I want to integrate over, right? So let's pick a point in the middle and see which is the greater function. I'm going to pick 0 because it's so easy. So f of 0 is 0 and g of 0 is minus 6. So clearly this is going to be the greater function. Okay, that's the third way to do it. It will get you out of a jam if the other two methods are unavailable. You don't have a calculator or you don't want to just do it and get it wrong the first time. Okay, another question?
So for this problem, you could do the integral of either versus the integral of either, and you would get the same number, just negative,
Correct.
positive, and then you would just absolute value
Yeah.
it, and that would be right.
That works. Yes?
So then for two functions that like they overlap each other multiple times, so like question number 16, could you like find like the integral of like the first part where one of them is over the other and then just do it again except flip the functions, if you get what I'm saying?
I mean, I would suggest you...
Or do we
Yeah.
just find the integral just of the
Yeah.
whole thing?
Let's say you have a function, two functions, and they do something like this. All right? And we'll call this A, B, C, and D. And what you want is the integral of the absolute value of f of x minus g of x from A to D. Well, let's just split that up. A to B plus B to C plus C to D. And then compute each integral, and I guess I'm going to do a little hand wave here. Since we know that they don't cross in this area, we can take the absolute value outside. So computationally, you just figure out those three integrals and add their absolute values. Are we good? Any other questions? On homework? Why don't you, during the break, why don't you bring up homework that you want to turn in, you want to look at. So we've been looking at integrals, and we've been interpreting integrals as adding up some kind of area. And found areas that are piecewise, you have to break it up into pieces. We found the area between two functions. But while an integral is useful for finding an area, it's not inherently an area that you're adding. You're accumulating values on a function. If that function represents, the y-axis here, and of course this is an area. But integration can be useful for other things. So today we're going to start looking at using integration to find the volume of a solid. And there are a few different methods to do this. We're going to start by learning something called volume by slicing. So what is volume by slicing? Well, if I have some solid. Let's say it's, I don't know, kind of this worm-like thing here. And I take a plane, and I see where this plane intersects, right? Now, you can think of this as having a little bit of thickness, a little dx. Now, if I have some function, f of x, or actually, let me call it a of x, because it's an area. So, for example, I have a of 0 here, and over here, a of, give it a number 9. So here I have a little a of 4. If I have an area function, it tells me along the way through this object what the area is, then I can compute the area of this solid as the integral from where I want to start and where I want to end on their volume as the integral of the area across this. Now, let's start with a really, really simple example. That you already know the answer to. let's take a, we call it a beam, whose cross-section is a square. Let's say this is a beam that's length 10, and the cross-section is a 1 by 1 square. So the area function is just 1 times 1, or 1. And we integrate from 0 to 10 this area function. That's going to be what? That's going to be integral of 1 from 0 to 10, which is just x, 0 to 10. So it's just going to be 10x. It's just going to be 10. And that's, of course, the volume of this beam. We've taken a slice across, which doesn't vary. So that's the really simple example. Now, the next example I want to do is this is like something we already know, but it's like this is kind of a dream come true. If I have a sphere with radius r, who can tell me what the volume of that sphere is? I heard 4 and r cubed over 3. Is that it? Pi, yeah. 4 thirds pi r cubed. Something we might have learned in geometry. We might have learned it and forgot it. But I want to show you now that this actually, you don't just have to memorize it anymore. You can compute it. So the way we're going to compute it, we're going to look at a circle. And there's a lot of symmetry here, right? In other words, the left side is the same as the right side. And also the top is the same as the bottom. So instead of trying to find the volume of the entire sphere, I'm just going to look at this part of the sphere in the upper right-hand side here. But first I want to look at this circle. Right? I know its radius is r. And I know using the Pythagorean theorem that if this is x, this is square root of r squared minus x squared. So what I want to do is take slices of this. Now you have to see this is a sphere coming out of the board here. And in each x, I want to take a slice which is, what would the geometric shape of these slices be? Be a circle, right? Put a plane through a sphere, you get a circle. So, okay, so how does that work? So each of these circles, my area function with respect to x is what? Well, at 0, this is just going to be pi r squared, right? And over at r, that area is going to become 0. So the area is the area of a circle whose radius is what? With respect to x. In other words, here I'm going to have, draw this a little better. I'm going to have a circle that comes out of the board here and goes in. So what's the radius of this circle? If this is x, it's distance from the origin. What's this radius here? It's on the board here. Right? Pythagorean theorem tells me since the radius of the sphere is big R, that this little r is just going to be the square root of big R squared minus x. Okay, so my area function is just going to be pi r squared, but little r is the square root of big R squared minus x squared squared. So what I want to do now is integrate from this side of the sphere out to the radius. I want to integrate from 0 to the radius. This area function, but I'm going to multiply it by 2, right? Because I want, I want to get both sides of the sphere. So the area function, again, is square root of pi r squared minus x squared squared dx. And now simplifying, this is 0 to r, take the pi out, r squared minus x squared dx. And now this is an integral that should be fairly straightforward. 2 pi times big R squared x minus x cubed over 3 from 0 to r. I'm going to have to erase my area function here, but okay, so what is this? 2 pi times r cubed minus r cubed over 3 minus 0 minus 0. So this is 2 pi times 2/3 r cubed, which of course is 4/3 pi r cubed. It's just what we were hoping for. Okay, any questions on how I did that? Again, the idea is we're taking a slice and we're moving it across the x-axis, integrating the area function. All right. Another example. Are you okay? Yes. Question? No. Okay, I'm going to take another problem from basic geometry. We're going to try and find the volume of a cone but specifically a cone that is centered along the x-axis here. And let's see. So at 0 it's just a point, but out here at L, it's going to have radius r. So again, we need to figure out what the area function is with respect to x. Well, we know the area of a circle is pi r squared. So really what we need to know is for each little radius, for each x, what the little radius is. Well, we're going to figure this out using similar triangles. Our big triangle is this one. So the ratio of this length, the radius to the length is big R over L. And that tells us that the ratio of R to X is equal to this. So now we can solve for R here. R equals X capital R to L. And our area we know is pi r squared. So our area is going to be pi times x squared r squared L squared. Everyone see that? In other words, I've got this cone. At its extremum, its radius is big R, and its length is the base height here, I guess, is L. And that gives me that this ratio is the same as little r to x. So I know this radius. And now I can find my area function, which is the area of this circle here. Okay, so now I want to integrate that from 0 to r. And that's pi x squared r squared over L squared. There are a lot of constants here. It would be easier to pull them out, right? Pi r squared over L squared. 0 to r of x squared dx. X squared, antiderivative is just x cubed over 3. And continue on up here. Pi r squared L squared r cubed over 3. This isn't turning out right. What did I do wrong?
The upper limit.
Oh, the upper limit. Sorry, the upper limit is not R. That's what it gets to. The upper limit is L. Thank you. Okay, so this is then L cubed over 3 minus 0. So a little simplifying, pi r squared L over 3. Which, if you recall your geometry, if you have a cylinder with height L and radius R, its volume is pi r squared L, and the containing cone is just 1/3 of this. Okay, why don't we take a break for 5 or 10 minutes? If you have homework, you can hand it in. If you have other questions, you can come up. If I missed you when I took attendance, let me know. Zimin is here, right? Zimin Khan? Where are you? I always have to look. Okay. I always have to look. Xijing Zhao? More questions? And, I guess this is also Zimin. Isn't Zimin here? Zimin? Here. How are you? Okay, I know you all can't wait to try one of these yourself. However, I have a couple more examples I want to provide you with. The next example is just to show you that this whole volume, this slice idea, can also work if we want to integrate along the y-axis. So, for example, if I have the function f of x equals x cubed, which looks sort of like this, and I want to find the volume I get when I spin this around the y-axis. We're going to say from 0 here up to 8. So again, the volume is just we're going to take slices this time along the x-axis. So I'm going to have an area function in terms of y. So again, I want to know what my x value is here in terms of y. So I start out with y equals x cubed. And of course, that means my x equals the cubed root of y. So if this is y, then this is the cubed root cubed root of y. And that's now the radius of the circle here, the area of which is just going to be pi r squared, but as we said, r is cubed root of y. So this becomes the integral from 0 to 8 of, again, take the constant out. Cubed root of y squared is y to the 2/3. And again, we have a fairly simple integral here. Y to the 5, simple antiderivative, y to the 5/3 divided by 2/3, which is just times 3 divided by 2, 0 to 8.
In pi.
And now I have to figure out what the 8 to the 5/3 power is. Well, the cubed root of 8 is 2, and 2 to the 5th is 32. So I have 3 times 32 over 2 minus 0, which is just 3 times 16, or 48. So that's how I would find this volume of this parabolic bullet. I guess it's a bullet. Okay, any questions? In other words, you know, if we can slice along the x-axis, we can slice along the y-axis. Okay. Now for the piece de resistance. We're going to do what we call a washer, or a ring. Instead of slicing, we've been slicing out in these last two examples circles. We're going to slice out a ring, or a washer, or there's another good vocabulary word if you're interested in that. Two ends or one? Two annulus. Annulus. Okay. So the problem says let the area between y equals x and y equals x squared, let me draw that for you. So y equals x squared, y equals x squared. So we have an area here. And we want to spin this around the x-axis. This area, by rotating around, we get a volume. It's a little strange looking. Okay, so how are we going to do that? Well, now instead of a ring, now instead of a circle, we actually have a ring that we want to cut out from the circle. So we need to figure out the area of this ring. So the area of this ring is going to be pi times, I'm going to call the big radius r, minus the area of the little circle, I'll call little r. So now we have to figure out what big R and little r are. So big R is, if we have x as the distance on the x-axis, then big R is just going to be x. Little r, however, if we come along the x-axis, little r is x squared. That's this distance here. So our area function becomes pi times x squared, that's plugging in here, minus pi times x squared squared, that's this function over here. And so our integral becomes from, well, we know it's from 0, but we have to figure out how far we're going to go. Oh, we can give away the answer, huh? If we set these two equal, x equals x squared, and again we subtract x from both sides, we can see that by factoring that these two curves meet both at x equals 0 and x1. All right, so yes, thank you. It is 1. I'm going to take the pi factor out. X squared minus x to the 4th. So again, keep in mind this is my washer area, and I integrate along it. And what do I get? Pi times x cubed over 3 minus x to the 5th over 5 from 0 to 1. So that just becomes pi times 1/3 minus 1/5. Rest is 0, right? So that will be 2/15 pi. So that's my volume of this strange volume created by cross section, which has cross sections of rings. That's again called the washer method. Okay, that's pretty much it for the slice method. I have some problems for you to work on, and we'll give these a try now. I don't know how to get this to you.
So you multiply this one. Okay. No, it sounds right.
I'm guessing.
So I have y equals x squared,
Did you say capital?
and I'm going to revolve it around.
Did you?
I said capital C.
Oh, wait, see, it was not first one, so this one.
So
I guess
That's my signature.
so I just have to review it.
Huh?
I just have to review it. I think what's your last name? What's your last name?
So when is that?
I'm going to revolve this function y equals x squared around the x-axis. So my area is what? It's
Oh, no, it's
pi r squared, where
yeah.
r is what?
Hey, why do you do a constant?
Huh? Yeah.
X squared, yeah, R is x squared. So the area function is pi x to the fourth. So we just need to integrate that on that interval.
You did, very nice.
To get our volume. Okay. Number two, we again have y equals x squared, but now we're revolving it around the y-axis. So this time I'm going to have, I'm going to integrate along the y-axis. So my
No, just actually pi. I didn't do that.
area function here, these are circles,
Wait, just kidding. It's not.
so it's going to be pi r squared, but now what's r in terms of y?
Square root of that.
Yeah, we have to solve for x. X equals square root of y. So now the area function is just pi x squared, which is the square root of y. Wait a minute, did I say that right? What's r? Oh, r is x, yeah. So it's the square root of y squared equals pi y. So now our volume is just, again, we're going from 0 to 1. But now it's pi y dy. A little simpler. All right. Some brave soul want to try number 3. I hope when you see like something like e to the x, you don't get scared. It's just another function. Right?
Wait, did you end up getting this?
For 3?
Yeah.
It's pi over 2. Pi over 2 minus pi over 2.
Oh, how are you doing this? One day? Why?
Y equals to the x, which,
Where'd you take away?
what does that look like?
Oh. Really? When did you drop?
And again, you want to spin this around the,
Yeah. No.
Wait, you got the W?
Yeah, I got it.
It's better than a C, right?
yes,
No.
About the second question, the interval
But I-
is from 0 to 1.
So like
And
the drop.
Wait, when is
the
it?
square,
It's like 2 weeks.
the square
No,
root
that's
dropped
that's
it?
the-
I think the drop was like
No, the W date.
Oh, the W day. Oh, that's
That one was
easier.
way further, but
Oh.
we learned it way.
we're talking about this
So
problem.
they're out of order.
Yeah, this.
So,
interval is from 0 to 1.
so we have y equals x squared, right?
I already did
The word
this.
So R is x, right? That's the radius. But in terms of y, x is the square root of y.
It's actually
To
not
multiply by 1 half,
Where?
the square.
Yeah, I just looked okay. Like, I've
It's a circle. The area of the circle is pi r squared, right?
Wait, when did you?
Oh,
do it?
you're
What class were you?
Do we need to do that?
where does the half come in? Because this is not a radius and not a diameter. The area of a circle, I know you know this, I'm just stating it for the record. The area of a circle is pi radius squared of the circle.
Because I started going here in high school, yeah.
So the area in terms of y, where we are in the y-axis,
But the interval is about x. And is from 0 to 1.
interval is from 0 to 1 on the y-axis. I wasn't explicit about that. Oh, did you think I was from 0 to 1 on the x-axis?
Yeah.
That's the same, right? Because
Well, no.
1 squared is 1, right? So it's the same. But I don't see where a half comes in. Again, it's just, this is the area function, pi r squared, and r is the x value, but in terms of y, it's the square root of y. So it's pi square root of y squared, or just pi y. I don't know, I don't want to go on if it's not clear, but do you think there's something wrong? Because you should come up and point it out. It could be. I make mistakes, so don't.
I think right.
You think I'll have it? Is everyone else happy?
Oh, here is.
Everyone else happy with that? Okay. Here again, we have an area function. We're going to integrate along x. So the area is pi r squared, where r is what? In terms of x. R is just e to the x. So this is just pi times e to the x squared, which is pi e to the 2x. So we integrate that to get our volume from, oh, it's 0 to 1 again. Pi e to the 2x. I think I'm going to do this one just for fun, right? So that's pi times e to the 2x over 2, right? The antiderivative from 0 to 1. So that becomes pi e squared over 2 minus 1 or pi over 2 times e squared minus 1. So much for the easy stuff.
Right. So it becomes each to two.
What's the quiz going to be like? Can you think of your worst nightmare and then make it like 3 or 4 times? No. I haven't written it. I don't know what it's going to be like yet. It'll be like the first quiz except different material. And it'll probably be a little
already really simple.
shorter
Because
because
like,
last
no, it's the same.
but there will be fewer. There were a number of really trivial questions on the first one. You know, like there was a question on the first one, something like this of f of x, where f of x is even, right? Or odd. If it was odd, then you know it's 0. So it's trivial, right? I don't think there'll be any trivial questions. There'll be some easier ones, some harder ones.
Oh wait, no, I didn't do it right. I just didn't suffer.
Okay, so everyone got number 4 already, right? Everyone's really
Yeah, of course.
okay.
I got it.
So let me
I got it.
wait until everyone settles down.
Yeah, but I don't live in the building. It's like hard time. Because
So the problem you're having with number 4 is not calculus.
yes, it's hard.
It's geometry. Okay? Take a look at number 4.
I mean, I don't into anything.
So I have a circle, and in the middle, I don't know how to, I have this equilateral triangle that's the size of the diameter, And then as I move out, it gets smaller and smaller and smaller. So over here there's a little tiny triangle, and over here there's kind of a big equilateral triangle. And that triangle, the area of that triangle is what you have to figure out in terms of x. Since the radius is 1, if you look at a, what shall I call this? It's a half chord. It's a half chord. Chord is, a line from one point on a circle to another. So this half chord here, we know if this is x and this is the radius, which is 1, this is the square root of 1 minus x squared. And that's half the base of my equilateral triangle. So we all know the formula for a triangle. The area of a triangle is 1/2 base times height. Well, this is half the base, so we know it's 1/2 times 2 times the square root of 1 minus x squared times height. Now we have to figure out what the base is. And this is really, no pun intended, really basic geometry. For an equilateral triangle, let me just remind you all of this. For an equilateral triangle, this is the base, and then the base is going to be the same, right? So this is 1/2 the base. And then this height here is, well, we can use the Pythagorean theorem if we don't memorize this, which we should, right? It's going to be the square root of b squared minus 1/2 b squared, which is going to be square root of 3 over 2b. This is the magic number you want to remember. It's also the cosine of certain angles, right? 30 sines and cosines of 30 degrees or 60 degrees, right? Square root of 3 over 2 and half, right? So, okay, so this is square root of 3 over 2b. So we look back here, and h, we can replace h with square root of 3 over 2 times 1 minus square root of 1 minus x squared. That's our area function. Now, written out like that, it looks really ugly. But if we simplify it, these 2's go away, right? And we end up with square root of 3 over 2 times 1 minus x squared. That's our area function. From there, it should be pretty easy. I suggest you use the fact that this is an even function, right? And instead of going from here to here, let's just go from 0, 2 times 0 to 1, right, the radius, this area function, square root of 3 over 2, 1 minus x squared. And the rest should be pretty easy.
The square root minus x squared is already the half of the base.
1/2, 2 times this. This is only half the base, right? 2 times this, that's the base, times the height. Okay. Okay, this is 2 times the square root of 1 minus x squared times the square root of, oh. So this times the square root of 3 over 2, right? So the base is 2 square root of 3, wait. 4 square root of 3, 1 minus x squared, is that what you're saying? No. I'm getting punch drunk here. I can't even multiply. All right. This times the square root of 3 over 2 is just the square root of 3 times the square root of 1 minus x squared. Ah, is that what you're saying?
Yes.
Thank you. You get a gold star in my head. So I get rid of this, right? And now I get the right answer.
Wait, what? The
Take
bases
that
are
out.
basically
All right. Any other questions? Okay, so there's some homework problems that you will do. I recommend if you have some time tonight or tomorrow, you at least try some of the homework problems that are on the web.
Is this type of like triangle craziness, is that going to be on the test?
Could be.
You actually
How mean I want to be, right? Okay.
I just try to read it.
I try not to make it a
I'm like, that looks like a
class of solving geometry problems. There's some basic stuff. Did you understand this? Then you should be fine. Okay, thank you. And I'm here if you have some questions about anything.
Wait, no. That's like,
我建议说你们定好，现在还发给我。
然后到再
I got study with it.
You always seem so scared.